As the farming industry goes through extensive innovation, vertical farming has emerged as an important solution for future farming. And as you can imagine, lighting plays a crucial role in vertical farming. We will present our latest lighting solution specially created for vertical farming. Vertical and indoor farming is under the spotlight, and capital inflows into vertical farming have drastically increased. Venture capitalists associated with companies like Google, Amazon, and IKEA are all investing money in this industry. The investment is mainly driven by these two reasons. Improved living standards are leading to higher demand for more fresh, healthy, and organic food. Also, the legalization of medical and recreational cannabis is driving the horticulture industry to begin mass indoor production. Since LED is the sole source of light in vertical or indoor farming, a full spectrum is required. Full spectrum covers a wide range of wavelengths and promotes well-balanced plant growth in a cost-effective way. Unlike the narrow spectrum's purple light, white-based full-spectrum light is just like normal lighting, which is more comfortable to human eyes. It enables easier detection of diseases and creates a pleasant work environment. 3 things must be taken into account when choosing horticulture lighting. These key considerations are spectrum, efficacy, and reliability. Later, we'll move on and explore each of them. The Samsung Horticulture LED lineup is prepared to address these key considerations. It provides wide-spectrum options that cater to a variety of purposes. Samsung's renowned top-class efficacy enables more productive horticulture lighting while saving operating costs. Lastly, our product's robust durability allows for reliable operation. We offer a wide-spectrum selection from 450 nanometer blue to 730 nanometer far red, necessary for plant growth. A simulation tool is also available for free that you can use to design a target spectrum and performance with Samsung LEDs. Spectrum changes the way plants grow. Therefore, it is very important to design the right spectrum. Here, we conducted an experiment on leafy greens with narrow and full spectrums. Conditions were strictly controlled and the experiment was repeated 3 times with different batches to guarantee accuracy. The results showed that 10% more fresh weight was obtained under the full spectrum, and this indicates that spectrum matters for plant growth. Also, a cross-section analysis of the leaves showed good overall cell structure conditions under the full spectrum. This proves that full spectrum can improve both the quantity and quality of plants over the conventional narrow spectrum. With our technology, plants can be engineered to have a certain color, taste, and better immunity by changing the spectrum, and there is lots of interesting research in progress regarding spectrum engineering. Light spectrum has influence on plant morphology, and plant colors can be changed by spectrum engineering. San Francisco-based vertical farming company Plenty has their own lighting recipe to change the taste of veggies, and they sell different flavored salads that do not require additional dressing. Also, a report from the Lighting Research Center claims that specific nighttime light treatment on basil can prevent downy mildews. Horticulture lighting uses different figures of merit compared to general lighting, and it's important to remember photosynthetic active radiation, PAR, photosynthetic photon flux, PPF, and photosynthetic photon efficacy, PPE. PAR light is the wavelengths of light within the range of 400 to 700 nanometers, which drive photosynthesis. PPF measures the total amount of PAR produced by a lighting system each second. Its dimension is micromoles per second. PPE refers to how efficient a lighting system is at converting electrical energy into PPF. Its dimension is micromoles per joule. LED efficacy is crucial in horticulture application, and Samsung provides industry-leading high-efficacy LEDs. The PPF and PPE of LM301H are 10% and 8% better than average LEDs. Samsung is committed to providing the best efficacy LEDs and we are continuously developing more innovative technologies. Here, the importance of using high-efficacy LEDs is highlighted. High-efficacy LEDs can be operated at higher currents at the same efficacy. In other words, we get more ppf out of single LEDs from high-efficacy LEDs without losing PPE. As a result, the number of LEDs can be significantly reduced by using high-efficacy LEDs when we design a lighting system with a target ppf and PPE. By rule of thumb, a 10% lower efficacy means twice the number of LEDs, which is 100% more. So it's not just a 10% efficacy gap, it can be a 100% gap in the number of LEDs. Another important advantage of using high-efficacy LEDs is their energy-saving capability. This is especially true in vertical or indoor farming institutions, which consume a large amount of electrical energy, which can be saved dramatically by using high-efficacy LEDs. Now let's talk about a performance roadmap for white LEDs. Mid-power white LEDs surpassed 3.0 micromoles per joule in 2018 and are expected to reach up to 3.16 micromoles per joule in 2020. This means over 3.0 micromoles per joule white-based LED fixtures are available. We will start to see some of them this year. In the case of colored LEDs, we have higher expectations than white LEDs. High-power red LEDs are breaking 4.0 micromoles per joule and expected to reach up to 4.15 micromoles per joule in 2020. We can expect more than a 15% improvement in the next few years, and this is mainly coming from our advanced chip technology. We must also look at the possible downsides of LEDs. There are mainly two types of LED failure modes in horticulture lighting, and they are blackout and performance degradation over time. Blackout is often caused by wire failure inside the LED, and performance degradation is related to material degradation due to chemical reactions. Poor process control of wire bonding and frequent on and off switching of LEDs in the field can cause wire failure. To prevent this issue, Samsung utilizes a flip chip type of LED as a solution, since it does not have a wire at all. The flip chip type of LED also has better thermal dissipation than normal epi-up types, and wire failure caused by frequent on and off can be minimized as a result of less expansion and contraction of the LED materials. To prevent a chemical reaction, LEDs with protection schemes are desirable. Ingress protection, or IP rating at the fixture level, is not enough because IP is against solids and liquids, not against gases. So, the LED itself should be sturdy. Covering a silver lead frame with a reflector structure or coating everything with a protective layer are some of the technologies that we are using right now. When we compare horticultural LEDs and normal LEDs under sulfurization tests following the International Electrotechnical Commission (IEC) standard, horticultural LEDs show much better performance maintenance. LEDs used in horticultural applications should be different from a normal LED in terms of reliability. Because LEDs are the only light source, efficacy is the key factor in vertical farming due to the importance of cost savings. We provide a variety of white and color LED solutions with excellent efficacy for users to choose from. Thank you.